Hi, I'm Willie. Welcome to my channel. Thank you for being here. I appreciate each and every one of you. And what we're going to look at in this video is an industrial switch by Teltonika Networks. It is a DC powered switch, and you could find a power brick, cut the ends off, try to wire it up. But I've worked on industrial networks, industrial switches, routers, backnet setups, for years. But I've not had a proper lab setup because I really was just configuring equipment. I wasn't physically deploying it. Well, now I'm getting into physically deploying it, and you can actually see kind of in the rack, there's the switch, there's my DC power supply. You can see the cable coming off of it going up to where it's plugged in. I'll show you a couple pictures of it here in just a second. And I am going to be working on some videos tomorrow, or when you see this today, that deal with DC power. I'm going to show you all the tools that I use. And I've been teaching myself this from the little bit that I can find, because I didn't find one good resource that I was really happy with. I do have a friend who's an electrician, but he's busy and I don't want to bug him with it. So I've been doing some reading, watching some other people on YouTube, trying to put this all together so that I've got a really good understanding of it. So I'm going to do a video on why we use DC power in industrial settings. I'm going to go over some of the light differences between DC and AC power. And then I'm going to show you all the tools and everything that I use, because I've got 3 more switches that have to be mounted up there on the DIN rail. And real quick, what I'm going to do is I am going to show you the pictures of the switch. So here you can see the DC power supply, and you'll notice that these cables all have ferrules on them, and that's because I did buy the tools to actually put ferrules on instead of just taking the wire and you know, twisting it up and shoving it in there. I wanted it to be nice. Back here you can see where this is mounted in the rack, and when I do that video, I'll leave links to everything that I purchased. Let me go to the next one so you can kind of get a side shot. So this is the Teltonika TSW202. It's an industrial switch. It's got 8 ports of PoE depending on how much power you supply it. So depending on how much power you supply it depends on how much PoE it can actually output. And then it's got 2 SFP cages down here. They are just standard, but you got to remember these are used in industrial type settings and building automation control, things where you don't need 10 gigabit. Gigabit is probably actually overkill for a lot of these. So let's bring up the switch here and take a look. So like I said, this is the TSW202, and I want to thank Teltonika for sending this out. And Teltonika, I am sorry that it took me so long to get this video out, but I wanted to actually mount this thing properly. I didn't just want to lay it on a desk, and I wanted to create a lab environment where I can mount multiple different types of switches. So I do have some other ones that are coming. So when you first log in, you get a really nice overview page here, and you can see that port 8 is our uplink. You got your SFP ports over here. You've got a little legend that tells you what each of the colors or the icons mean. Down here we have our RMS connection, which is Teltonika's. They have a cloud-based, and you can get it on-prem, but they have a management solution where you can manage all of your Teltonika hardware. But I do not have this registered to that. And then over here you can see under functions, QoS, port mirroring, loopback detection are all off. Jumbo frames and spanning tree are on. We've got HTTP, HTTPS, CLI, and SSH access enabled. You can see that my main interface has got a DHCP address, and then it has a fallback address of 192.168.1.2, which if I manually configured my machine, I would be able to get into that if I put a static on. Over here under system, you can see the serial number, hardware version, our firmware version. This is running the latest firmware version. And then we can go into the network status. We can look at the ports and the forwarding tables. We can actually dig into each port. It'll tell us how much traffic is going through there. It'll tell us how many errors we have. We can look at our spanning tree, and you can see right here that RSTP is enabled. We are forwarding. This is the designated port This does have a built-in DHCP server, and then you can come in here and we can look at our routes to all of our different networks. Under network, we can come in, we can look at the interfaces, and we can configure these interfaces here. We can add new interfaces. We can take a look at all of our VLANs, and we can do, you know, different tags or different untagged on each port. MRP is a protocol that allows you to have switches. Basically, I'm oversimplifying this, in a ring, and if a part of the ring goes down, it'll reroute the traffic automatically the other way. Here we've got full QoS, so we can do port priority, DSCP marking, 802.1p, and we can actually do bandwidth control per port. We can also turn on storm control. Here we can put in static routes. I don't have any. Here's our spanning tree settings. We can dig a little bit further into the ports. So as you can see that jumbo frames is on, you can turn LLDP on or off, IGMP snooping, multicast courier. We can come in here, we can turn PoE on or off. We can change the port speed settings. We can isolate the ports. Here's our port mirroring, our loopback detection, which I have disabled, and then it even has 802.1x for those of you who are interested in that. And this is where you set up your radius server. Here's the DHCP server. I'm not running that. And then under services, you've got your RMS connection, Profinet, LLDP, Ethernet IP, OPC UA server configuration. We've got SNMP. So this will do SNMP version 1, 2, and 3. We could set up the communities there. It's got Wake on LAN. And then under system, we've got administration. So you can change the name, the host name. We can change what the reset button does. We've got date and time. Of course, NTP is enabled. We can come in, we can add other users besides admin, give them different roles if they need to get into the switch. Here's our access control, so we can turn SSH on or off. Here we can see if we've had failed login attempts, things like that. Under profiles, we've got configuration profiles. We've got a scheduler in here. This is a very full featured switch. We've got network diagnostics, where we can come in here and ping. We can do trace routes, NS lookups. We can do cable diagnostics. We can do auto reboot. So if ping fails, it'll auto reboot the switch. We can do a reboot scheduler. Here's where we can back up our config or restore our config. Got some more troubleshooting here for logging. We can come in here and look at all the different logs. Here's the event log right here, and it's got a pretty thorough log setup. Here's the command line, so we can actually log into the command line right from here. We can do a full factory reset, or we can reset the system settings. Now under package manager, I was interested to see what else that we could do with this switch. It's going to load the packages, but check this out. We can put BGP routing on here, EIGRP, which is Enhanced Interior Gateway Routing Protocol, FRR routing, which a lot of other routers use FRR. I think for BGP, for like the unified gateways, I believe they use FRR. It can do OSPF. It can also do RIP. So those are the packages that are available. If you have other packages, you can actually upload them here. And then our firmware, we can update it by uploading a file, or I just went out to the Teltonika servers and updated it that way. So what I'm going to do real quick is I'm going to pull up the tear sheet about this, so we can talk a little bit more about the environment and things like that. So here is the web page. I'll leave a link to this down below, and they've got a 3D model that you can you can rotate the device. You can see that's how it's attached right there to our DIN rail mount right there. So like I said, it's 10100 gigabit, fully managed, and it can do 802.3 AF and AT and alternative B on the PoE. So if we had enough power going into it, we could do 30 watts per port. One of the things that I was looking at with this switch was the temperatures, the operating temperatures. Right here you can see that the power connector is a 2-pin industrial DC power socket. As you saw in those pictures, I have the cables plugged in there. Now the input voltage range is 7 to 57 volts, and obviously you got to have the higher the voltage input, then you're going to be able to support more PoE devices on that. Now, it is all aluminum. It is painted black, but it is aluminum, and it's a really nice looking piece of hardware. And here's the operating temperatures: negative 40 degrees Celsius, which I believe is also negative 40 degrees Fahrenheit. We'll run that here in a second. To 75 degrees Celsius. Let me pull those numbers up. So yeah, so negative 40 degrees Celsius is negative 40 Fahrenheit, so that's very cold. And then 75 degrees Celsius is 167 degrees Fahrenheit. So this switch can be put in some environments where you basically have no temperature regulation, and it's just going to keep plugging along. Let's see what else. All kinds of different standards that they've got here. I'm not even going to pretend to know what some of those are. I'd have to look them up. But you can see that it does have FCC approval, and it has approval of all of these other regulatory bodies. So you can use this thing in a lot of places. And there's just something about industrial switches. We can just slap these things up, and they just seem to just run and run and run and run. You're probably asking yourself, what's the price for something like this? Well, let's look it up real quick. So you can pick this switch up for about $139 US. And if you need a switch that is tough and needs to go into these types of environments, 139 bucks, I think that's pretty cheap for a fully managed switch with gigabit ports, DC powered, all that good stuff. So that's kind of the next thing, right? So what do you want to see? What am I missing with DC power that I didn't talk about? I mean, obviously it's more efficient because AC to DC, you have to rectify it, and there's loss and all kinds of things, right? So that conversion is not very efficient. DC power, in my understanding, is more stable. And a lot of the electronics are actually designed to run on DC, and DC provides, instead of fluctuating power, will provide a steady power. And if you're using battery banks and things like that, since there is no conversion from AC to DC, it's much more efficient that way as too. I've got about 12 things I'm going to say about that in the video that's coming up about using DC power. But let me know down in the comments what else I need to know, and we can kind of take this journey together. This is the first switch that we are going to look at. I've got, like I said, a few more, plus we've got that Grandstream switch that can be DC powered. So they're all going to get mounted back here on the DIN rail across the rack. That power supply may not be big enough to run them all simultaneously, so I might have to upgrade the power supply. And I've got a check this out. So you bring your power in here, so you come off of your power supply, and then we can actually split it out to 5 other devices. So I'm going to mount one of these up there, but I might, like I said, I might have to upgrade the power supply before I do that. But if you've got questions about this switch, let me know. I think this is a fantastic deal, and I could see these things getting stuffed in all kinds of weird environments. You don't have to power it with a power supply like this. Like I said, you could find a power supply, cut the wires off, shove them in there if you wanted. I'm going to use ferrules because we're also going to be doing some solar stuff. So I wanted to have the tools. I wanted to do it correctly. And that's the next video. I'm going to show you all the tools, and I'll do some close-ups of the DIN rail. And because I did order a rack mount kit for the DIN rail, which is why it's in the rack. So let me know what questions you've got. Let me know if there are things that I should concentrate on, because I really am just really starting to dig into the DC power, and I'm digging it, so to speak. And I don't know why I didn't do it sooner. Kind of kicking myself in the butt for not doing it sooner, but I'm jumping in with both feet. So let me know down in the comments what else I need to know, what I should look at, and let me know what you think about this switch for that price. I think it's fantastic. So if you've got any questions about the switch specifically, let me know down below. If you like this video, give it a thumbs up, subscribe, comment, share, follow me on Twitter and TikTok. Those links are down below, along with affiliate links, a Patreon link. And if you need IT consulting, head on over to williehowe.com. And whether it's networking, voice over IP, security, storage, wireless, you name it, fill out that contact form on the front page over there at williehowe.com, and someone will be in touch with you as soon as possible. I am posting a lot of this stuff on the community, so head on over to community.williehowe.com, sign up, and join the conversation over there. Once again, I'm Willie. Let me know down in the comments, like I said, what I need to concentrate on, other things I should look at, and we'll kind of go through this journey together. Once again, I'm Willie, and I'll see you in the next video.